So the topic for the day today is exponents that are real numbers, and specifically they are irrational. We've covered how to handle fractions as exponents, but now we're going to have things like square roots as exponents, and we're going to have pi as an exponent. But I will tell you, this is really very easy because you're going to use the same laws of exponents that you've been using all along. You're just going to be using them with different numbers. So a couple of things to review from chapter 6. If you have the same index of roots, so if this number here is the same, you can use the product rule. If it's different, you can't. If this number is the same, you can use the quotient rule. If it's different, you cannot. All right, and another thing, let's just review what we learned in our last lesson, which is x to the a over b power is the b root of x to the a, and we can write the a on the outside or in the inside. So at the bottom of this page, we have some examples. Real number exponents are exponents that can be rational or irrational. Irrational exponents include square roots that can't be simplified, such as the square root of 2, square root of 3, square root of 5, and so on, as well as the irrational number pi. So we're going to simplify each expression completely using the laws of exponents. Now, I have the same base here, okay? So here's the law that applies in this situation. X to the a over x to the b power is x to the a minus b power. We're going to apply that law here. You have square root of 2's as your exponent, but that's okay. All right, we're just going to use the same law. So this is 6 to the square root of 2 minus the negative square root of 2. All right, take the top one, subtract the bottom one. Minus the negative is the same as plus a positive. Square root of 2 plus the square root of 2, remember from chapter 6, gives you 2 square roots of 2. So this is 6 to the 2 square roots of 2 power. Now 2 square roots of 2 really means 2 times the square root of 2. All right? So you can leave this answer this way, or we can simplify it further, which is to write it like this. 6 squared to the square root of 2 power. And notice, the power here is 2 times the square root of 2. Still the same, just a different way of writing it. And finally, 6 squared is 36. So we can write this as 36 to the square root of 2 power. All right, let's take a look at b. Remember that in order to use our laws of exponents, we need to have the same base. We want to use this. X to the a times x to the b is x to the a plus b. Right now, we don't have the same base, but we can get the same base because I can write 4 as 2 squared. So I'm going to write this as 2 squared to the pi power times 2 to the 3 minus 2 pi power. Now, my laws of exponents tell me I can multiply these two powers. So 2 times pi is 2 pi. So this is 2 to the 2 pi power times 2 to the 3 minus 2 pi power. Next thing I'm going to do, add those exponents. So this equals 2 to the 2 pi plus 3 minus 2 pi power. And the plus 2 pi and the minus 2 pi cancel. So this is 2 to the 3rd power, which is just 8. So we haven't used anything that you don't already know. We're just using the same laws of exponents that you've been using before. We're just using them with different types of numbers. Let's turn the page. Okay, first example. Simplify each expression completely using the laws of exponents. Now, here's what I have. This is the law that applies. X to the a raised to the b power is x to the a times b power. So this is 3, whoops, I wrote a 2, that's not good. 3 to the 2 square roots of 2 times the square root of 2 power. Now remember, the square root of 2 times the square root of 2 is 2. Times this 2 is 4. So this is 3 to the 4th power, which just equals 81. All right, let's take a look at B. Now here's the law that's going to apply here. And if you can identify the law that will apply, that's going to help you a lot. So here's what we've got. X to the a over x to the b power equals x to the a minus b power. So all I'm doing is subtracting those exponents, because I do have the same base. It's 3. So this is 3. Now be careful when you do this. This is the power of 2 plus the square root of 7 minus, in parentheses, 2 minus the square root of 7. I have to subtract the entire exponent down here. So put it in parentheses. All right? Now, let me go ahead and simplify that. This is 3 to the 2 plus square root of 7, distribute minus 2 plus the square root of 7. The plus 2 and the minus 2 cancel. And you have the square root of 7 plus the square root of 7, which is 2 square roots of 7. And let's do what we did on one of the previous examples. Let's change this to 3 squared to the square root of 7 power. Now, the law that tells me I can do this is this law. I'm just going from this direction back to this direction. That's all I'm doing. But what it allows me to do is simplify 3 squared, which is 9 to the square root of 7 power. Still just using the same laws of exponents that you already know. Okay, let's take a look at C. This is great because I have all the same base. All right? So I'm going to simplify just the numerator. And the interesting thing is I'm going to use this. X to the A times x to the b power is x to the a plus b. So here's what I'm going to end up doing, and I know this. I'm going to add the square root of 12 and the square root of 27. So I might as well simplify these now. So the square root of 12 is the square root of 4 times the square root of 3. And the square root of 4 is 2. So this is 6 to the 2 square roots of 3 power. All I did was simplify square root of 12. Do the same thing here. This is the square root of 9 times the square root of 3. The square root of 9 is 3. So 3 square roots of 3. So this is 6 to the 3 square roots of 3 power. Divided by 6 to the square root of 3 power. Now in my numerator, I'm going to use this law, and this is going to give me 6 to the 2 square roots of 3 plus 3 square roots of 3. And this is divided by 6 to the square root of 3 power. Now 2 square roots of 3 plus 3 square roots of 3 is 5 square roots of 3. So this is 6 to the 5 square roots of 3 power over 6 to the square root of 3 power. Now, the law that applies here is this law. So I know I'm going to subtract my exponents. So this is 6 to the 5 square roots of 3 power minus the square root of 3 power. 5 square roots of 3 minus the square root of 3 gives me 6 to the 4 square roots of 3 power. And if I want to, I can rewrite it like this. 6 to the 4th to the square root of 3 power. And I just need to calculate 6 to the 4th. And that is actually 1,296 to the square root of 3 power. All right, let's take a look at D. Notice, I actually have the same base on the top and the bottom. That whole binomial is my base. All right, so here's what I've got. I'm using this law. X to the A over X to the B power is X to the A minus B power. So this is 2 plus the square root of 3 to the 2 plus pi minus pi power. Now notice, the plus pi and the minus pi cancel. And so here's what I have. 2 plus the square root of 3 to the 2 power. I can actually simplify this. Remember, I'm going to use FOIL. So this is 2 plus the square root of 3 times 2 plus the square root of 3. Now my first is 2 times 2, which is 4. My outers is plus 2 times the square root of 3. My inners is plus 2 times the square root of 3. And the last, the square root of 3 times the square root of 3 is plus 3. Combine like terms. The 4 and the 3 give me 7. 2 square roots of 3 and 2 square roots of 3 give me 4 square roots of 3. All things I've used before. All right, let's turn the page. This is something we touched on earlier in the year, and I remember it was something at the time that seemed quite difficult. Since you've seen this before, this shouldn't be as much trouble this time around. This is an equation where, notice, x is in the exponent position. And we're going to solve this equation. All right? And the way that we're going to solve this is that we want to get both sides of the equation to have the same base. If both sides of the equation have the same base, then whatever the exponents are on the two sides must be equal. And we create that equation and then solve that for x. So our goal here, when I look at this equation, I've got an 8 and a 4. I want to figure out how to get both sides to have the same base. Now we can use a base of 2. So here's what I'm going to do. I'm going to rewrite 8 as 2 to the 3rd. So 2 to the 3rd, then to the x power. Now 1/4, let's go over here, is 1 over 2 squared. To move that up into the numerator, I'm going to make that exponent negative. So this is 2 to the negative 2 power. Now on the left side of the equation, I'm going to use my power rule that allows me to multiply these two powers. And I'm going to get 2 to the 3x power equals 2 to the negative 2 power. Now notice, I have the same base on both sides, which is 2. So it means that those two exponents are equal. So that's the equation I'm going to use to solve for x. I have 3x equals negative 2. Divide both sides by 3. And I get x equals negative 2/3. All right, let's take a look at B. The two bases I have are 5 and 25. I want to have the same base. So here's what I can do. I can rewrite 25 as 5 squared. All right, so I've got 5 to the 4 minus t power equals 5 squared to the t minus 1 power. Now I'm going to use my power rule, which allows me to multiply these two powers. Notice, when I do that, I have to distribute that too. So here's what I'll have. 5 to the 4 minus t power equals 5 to the 2t minus 2 power. Now I have the same base on both sides. All right? So now I know that my two exponents are going to be equal. This has to equal this. So I'm going to write that equation. 4 minus t equals 2t minus 2. First, add t to both sides. And I get 4 equals 3t minus 2. My next step, I'm running out of room here, add 2 to both sides. And so I'm going to have 6 equals 3t. Divide both sides by 3. That will give me t equals 2. All right, let's take a look at C. Now, C, I have a 32 and a 2, but I need the same base on both sides. But I know that 32 is 2 to the 5th. All right, so that's what I'm going to do. I'm going to rewrite it as 2 to the 5th. So this is the cube root of 2 to the 5th equals 2 to the x power. Now, I'm just going to write this as an exponent, so in exponential form. So 2 to the 5/3 power equals 2 to the x power. I have the same base on both sides, so this exponent must equal this. And I have a simple answer of x equals 5/3. All right, let's go to our last example here. And I have a 4 and I have a 2. Don't think of this as a 1/2. This is a 2. All right? So let's rewrite both sides as with a base of 2. So I'm going to change the 4 to 2 squared. So this is 2 squared to the 2x power. Now, I don't want this to be 1/2. I want it to be 2. So if I flip it upside down, I've got to make this negative. All right? So in other words, distribute a -1 to this exponent. So this is 2. When I distribute a negative to this exponent, this is -1 plus 2x. On the left-hand side, I'm going to multiply my exponents. So this is 2 to the 4x equals 2. And I don't like starting it with a -1, so I'm just going to switch this to 2x minus 1. Notice I haven't changed any of the signs. I just switched the order, which I can do. All right, next thing, I have the same base on both sides. So 4x and 2x minus 1 have to be equal. So set 4x equal to 2x minus 1, and we solve. Subtract 2x on both sides. And I have 2x equals -1. Divide both sides by 2, and that gives me x equals -1/2.